Are you struggling to figure out what's wrong with your vehicle? Is this what it feels like when you try to diagnose a simple electrical problem on your car? Well, you're not alone. Whether it's a mysterious warning light, maybe a blown fuse, a car that won't start, or a sensor that's failing, modern diagnostics can really feel overwhelming. And the one tool that can actually help you is a digital multimeter. If you're like most beginners or do-it-yourselfers, maybe you've avoided it. There's too many settings, there's too many wires, not enough clarity. I'm breaking down how to use a digital multimeter the right way, simply, safely, and effectively, so you can start diagnosing with confidence. No more guessing, no more replacing parts that aren't broken. Let's demystify diagnostics. I know there's a lot of choices out there when doing electrical testing. You need at least a basic multimeter capable of performing three basic functions. We need to be able to check voltage, which every multimeter will do. We need to be able to check resistance, and we need to be able to check current flow or amperage. If we can do those three things, you can get through the majority of electrical work that you need. There are other functions on multimeters. If you buy something that is automotive specific, like this particular tool, it might allow you to check temperatures. It might allow you to check RPM, engine RPM, might allow you to check diodes and capacitors. Those are more advanced features that you may not need on your meter. The only thing I would tell you is you want to have a high impedance multimeter, which most of all the new meters are. You want to make sure you're not going to do any damage to any modern computers or modern electrical circuits. Let me just give you a brief introduction to the three core principles that we'll be measuring with a multimeter. We've got the voltage, the resistance, and the current flow or the amperage. The easiest way to visualize this would be through plumbing. If you had a garden hose on the exterior of your house with a faucet on it, and if you turn the faucet off and the water pressure builds up behind the faucet because you haven't turned it on, that's your voltage. Voltage is just electrical pressure. So once we open that faucet up and we allow the water to flow into the garden hose, now we've got the water running full speed through the garden hose. That's your current flow. The amount of water or the volume of water that flows through can be measured just like we can measure current. The last thing we're talking about is resistance. And resistance would be the resistance to the flow. So if we were to put a kink in the hose, we've created a bunch of resistance in our circuit and the water will stop flowing as quickly. And those three properties are all related to each other, and you just need to understand that. There are some other things that we could talk about, like Ohm's law and the exact mathematical relationship between voltage, current, and resistance. There's plenty of charts out there if you want to get into that. But right now, I think if you just understand the basic analogy, it helps you understand electricity a little bit better. When we're using a multimeter, we really need to understand what it is we're measuring, because there are some options of how to configure the multimeter so that it does exactly what you want it to do. And probably one of the most important things you need to understand is the actual cable setup on here. So on the back, we've got some ports on here to plug these banana jacks into. And we basically got one for your positive lead that will indicate we're going to be measuring voltage or resistance or something similar like that. And then conversely, we've got another couple of red ports on the other side that are used just for measuring current or amperage. Okay, and it's really important that you understand this, because if you're trying to measure voltage and you're using your meter with it plugged into the amperage ports or the current ports, you're just going to blow your fuse right away and nothing's going to work for you. So it's really critical that you're only in one of the two low amp or high amp ports while you're measuring current. Okay, and while we're talking about that, I also wanted to mention, anytime we're measuring current in a circuit, it must be connected in line, so in series of a component. So we can't just piggyback off the back end. We got to disconnect it from the circuit. We put the two leads of the multimeter in line, one on one end, one on the other end, and we complete the circuit with the multimeter. Okay, and that's how this multimeter works, and all multimeters are going to work if the current is going to be measured without an inductance type probe. Okay, we'll get into that another day, but it's just really important that you understand measuring current, we're going to be in line, connected into the circuit as an integral part of the circuit. Everything else can be measured outside the circuit. Now I want to get to measuring resistance. This is another one that we're going to completely remove an item from the circuit before we test it. So if you're measuring resistance, we got to remove it completely. We're going to be checking any kind of continuity as well. You want to probably remove it from the system. So just important you understand those two things. When we're measuring voltage, we can go ahead and piggyback just about anywhere. As long as your red lead is in the voltage port, you're not going to do any damage. You can measure anywhere in the circuit and any voltage that your meter is capable of measuring. I want to talk a second about the settings on this particular multimeter. They should be similar on yours, whatever type of meter that you have. We're only worried right now about the three main things we talked about: measuring voltage, measuring resistance, measuring current. That's all I want to discuss in this particular video. Now, I want to remind you guys, we're making this content for you. If you feel like there's more in-depth stuff that you want to hear about, we'd love to hear about it in the comments. Go ahead and drop us a line down there. Let us know what particular problems you're having, what you want to test, something you don't know how to test and you'd like to know about. We're happy to make that content for you. We're going to follow these videos up with more in-depth content on diagnostic work and how to use a meter, how to use a lab scope, but you got to let us know what you want down in the comments. The first setting we're talking about here is the voltage setting. This one here has a squiggly line and a straight line. It just means on this particular meter we can measure AC or DC voltage. There's also another voltage setting that says MV millivolts. That's only if we're measuring less than a volt, usually somewhere between 0 and 1 volt. We've got another setting here. This one looks like a horseshoe. That's the resistance measurement. We're measuring ohms. That's what that symbol is. So anytime we're measuring resistance, we'll be in that one. And keep in mind, again, we're both using the same red communication port here on this thing, banana jack. We're going to be using the red port that's labeled as such, ohms and volts, okay, not the amperage port. I'm going to scroll through a couple other settings on here like temperature and microamps. There's two more settings in here, milliamps and amps. Now, most of the time we're probably just going to use the amp setting. Milliamps would be, again, probably something 0 to 400 milliamps, which is really 4/10 of an amp. So a very low setting, I would say, for our practices and purposes. We're going to just leave it on the amp setting. If you do use the milliamp setting, it's possible you could blow your fuse. Both of the amp ports on here are fused. And that means if you exceed the current rating, because the current is flowing through the meter, you're going to pop the fuse. So make sure you set it to your maximum first. We're going to start on amps. If we determine we've got 250 milliamps, we could always drop it down. But let's start at the high end first. You can read it both ways. It's just a little more accurate for a lower current reading if you use the milliamp setting after you've determined you've got less than what your fused capability is, which on this meter is 400 milliamps. There's a couple more settings in here I'm not going to get too concerned with. We'll bypass those, but let's get under the hood of the car and see some practical applications of how to measure voltage, resistance, and current. One of the simplest tests you can do is just checking the battery source voltage. It's important to know that everything in the automotive field works off battery voltage. Most of the things work off battery voltage. So if we have a low supply voltage, nothing else is really going to read correctly. Now, keep in mind your battery voltage was going to be displayed only when the vehicle is off. When the vehicle is running, we call that charging voltage. Once the alternator is producing the electricity, it's taking over for the battery. So you're going to see some disparity between your battery voltage and your charging voltage. Battery voltage we expect to be at 12.6 volts for a fully charged battery. Each cell inside a battery is 2.1 volts. There's 6 cells. That gives us 12.6. So the first test we can do, we'll set our ohm meter to the voltage DC setting. The DC setting on your meter might have just straight lines, straight and dotted lines, no squiggly lines, okay? That means you're measuring direct current. Everything we're doing on the car here today is going to be direct current. And then we want to make sure we're in the correct range when we're using the multimeter. It's really important that you understand the placement of the decimal point in the number that you're reading. Now, you have some options here. These meters will auto range. Usually if you hold the range function down for a second, the meter is going to switch to auto. That means it's automatically going to detect the voltage and give you the appropriate range. Perfectly suitable to use that. You just want to make sure, like if I'm looking here and this thing is telling me it's reading DC voltage and it starts with a decimal point, that means the voltage it would read on here is going to be less than 1 volt, up to 999 millivolts, which is less than 1 volt. So the decimal point placement is important. Watch what happens when I'm in auto range and we look for 12.6 volts on here. It's going to automatically move the decimal point for us. Okay, so you can see here now it says 12.560 volts. So we're really very shy, almost exactly on 12.6 volts. This is a fully charged battery. I would expect no problems here. Now the important part to note here is the decimal point did move for us. It automatically ranged for us. That's why we had it on auto range. If you were to select your own range and we put this down where it started with a decimal point, this meter is going to read OL or out of range probably because you're well above the scale that you've got it set to. So really just understanding the scales are going to be important when you're using a multimeter, especially if you're getting into current readings and things. One of the most important uses you could probably have for your multimeter would be for checking your fuses in your car. Now, there's fuse boxes all over the place. I selected one that's under the hood here because it has some easily accessible fuses that I can easily film for you. I want to show you the difference between a good fuse and a bad fuse using a multimeter, checking voltage on it. In order for me to do that, I got to have a bad fuse. I'm going to go ahead and take this fuse that's perfectly good and I'm going to blow it. This way we know it's not working, and then we're going to go ahead and insert it in place of the good fuse, and I'll show you what the difference might look like. So here we go, we're going to blow this fuse. This is what a short circuit looks like, guys. We've got this going directly from battery negative to battery positive. No load in the circuit. We have no resistance in the circuit, which means full current flow. We're going to run 600 amps or so, whatever this battery is, through this little 20 amp fuse, and it should blow it fairly quickly. Okay. That's what a short circuit looks like. This is why we have fuses in automotive applications and all other applications, because without a fuse, this could cause a fire. You know, this could burn a wiring harness completely down. I mean, you have a lot of problems that will happen without a fuse circuit. So never ever, if you're putting a radio in your car or something, never should you have a circuit that's not fused somewhere, whether using a fusible link wire or using a physical fuse like this. Make sure your systems are always fused. Before we get started here checking this fuse, I want to remind you guys that most automotive systems, at least for the last 40, 50 years, are negative ground systems. That means every circuit is grounded through the chassis, through the frame, through the body, through the engine. Everything metal is ground circuit. So it'll all work its way back to the negative terminal of the battery. So if you look at this here, this negative terminal is connected to the battery on this end, and it's actually just connected to the top of this strut tower, which is connected to everything else that's metal in the car. So anywhere we have a solid metal connection, you should have a good ground. So if you're checking voltage under the dashboard, you want to find a metal bolt somewhere that's connected to the firewall, that may be connected to the kick panel, the metal kick panel inside. Maybe you want to go inside a door jamb and find a bolt head that's screwed into the hinge somewhere. Anywhere that you can find your way to some metal on this car should return itself all the way back to the negative of the battery. Okay, negative ground system, that's how they work. So what we're going to do in order to measure voltage, we want to have our negative cable grounded from the meter, and then we're going to check the voltage in certain spots over here. And when we're checking a fuse, I want to check both sides of the fuse, and I want to determine if there's voltage there. Now, if I have voltage on one side and I don't have voltage on the other side, that's going to tell me that this fuse is blown in the middle, and we've got no continuity between both halves of the fuse. That means the fuse is no good. If I check for voltage on this side and I have the same voltage on this side, that means that fuse is good. There is some continuity within the fuse. We've got a solid connection on the inside. It's not blown. So we don't need to take every one out and look at it like this. You can clearly see this one's blown. We don't need to do that. We're just checking to make sure we have voltage on both sides. Now, there might be a scenario where you don't have voltage on either side. And all that simply means is that circuit is keyed or switched somewhere through a relay, through the ignition switch, something like that. And then all it means is that that circuit doesn't even have power going to it yet. So if you have no voltage on both sides of these terminals, that circuit is not even live, it's not active. If you only have voltage on one side and nothing on the other, you've got a blown fuse. If you've got voltage on both sides, you've got a good fuse. So let's go ahead and check a good one. I'm going to show you what that looks like on the meter, and then we're going to go ahead and put the bad one in. I'll show you what that looks like. So guys, we're going to check one side here. We've got 12.55 volts. We've got to check the other side of the blade. We've got 12.55 volts. So we know this fuse is good. Now let me remove this 20 amp fuse that we know is good. And I think you might be able to see here that it's connected versus this one that is not. This is the blown fuse at the bottom. You can see the middle portion is melted out of there, and that's what they're designed to do. So we're going to put this bad fuse in, and I'll show you what a bad one is going to read. Okay, so now we're going to check one side of the fuse. And you see we've got nothing really. I'm going to check the other side of the fuse. We see we've got 12.55 volts. I'll go back to this side, and you see we've got nothing. Now this fuse is not allowing current to pass from one side to the other. That's how we know it's bad. Now the fuse that we've seen there is just a standard type fuse. There's lots of other types of fuses. They all work the same though. They've got two blades on them usually, and they've got a little circuit breaker that's designed to melt in between them. When I'm looking in this fuse box here, I just wanted to mention there's another maxi fuse in here that doesn't have the two blades exposed in the plastic insulation or the plastic housing. The blades are actually external because these are bolt-in fuses. So On either side here, you'll see there's a screw that holds the fuse in place. These are what we call maxi fuses. They're larger current fuses. They may be designed not for 20 amps, so maybe 50, 80, 100 amps or more even sometimes. And these are a lot thicker, they're a lot sturdier, and they require a little bit better connection. That's why they're screwed in. But I want to show you here close up how you can test it. We're going to test these maxi or larger fuses the similar way we tested this fuse by using these little blades, but these are external. See, these blades are underneath these bolt heads, so we can actually just check the voltage on each bolt head. As long as we have our 12.6 volts, we know this fuse is good. You can see there's a window in there, but sometimes they're hard to see. This is the best way to check them, is measuring for voltage on both sides of the fuse. I was editing this film here and I just realized that I switched meters, but I forgot to tell you guys that there's lots of different meters out there, and I wanted to just give you some samples of a couple different ones. So we switched over to a fluke meter. It doesn't matter which you use, they all work the same. The next feature I want to go over here is the ammeter. That's how we're going to measure current in a circuit, and the most common place we use this in an automotive application, probably at least a few times a week, we're looking for parasitic drain on the battery, and that's basically when there's something activating while the car should be asleep. Something's drawing some current. Now, it could be something as simple as a dome light left on. Maybe your glove box light, you left the glove box open for some reason. You were grabbing something on the way out of the car and you forgot to close it. Modern cars will usually smart enough to power down those systems. They've got body control modules. So older cars like this won't do that. So I'm going to give you an example how this works and show you what it looks like. The first thing we need to do is to switch the leads around on this meter. So we were measuring voltage last. The next thing we're going to do is turn this meter off, and we're going to switch the red lead over to the amperage section. This one here is fused for 10 amps, so we can do anything up to 10 amps passing through this meter. Again, we're going to hook this in line, in series is what they call it. So we have to disconnect the negative cable, and then we have to put these two leads in between the negative cable and the battery. So first thing we need to do is disconnect the battery. I'm going to go ahead and take the cable off. Again, we're working on the negative side right now. Everything feeds through the negative cable, and that's why we're going here. And then what I usually like to do, I take some vice grips. This gives me something to clamp these little leads onto. I'll usually just pop this up on the battery somewhere. I'm going to put it up right here. A lot of times when I'm doing this, I'll be closing the hood or at least setting the latches on here, on the door, on the hood, anywhere. We want to make sure this car goes to sleep completely while we're doing this test. But for this purpose, I'm going to give you a little demonstration that's going to work well. And then we're going to hook this up to this pair of pliers right here on the negative side of the battery. And then this negative cable we took off is where we're going to put the other one. So I want to set this meter now to amperage. Again, this has two different settings on it for amperage. We've got direct current and alternating current. So right now I've got this set for the straight line with the dotted line below it, and that is direct current. And then we're going to just hook this positive side up to the battery cable right here. So now our current, anything that's going to be alive in this car, is going to be flowing back to the negative of the battery cable, through the chassis, back to the negative of the battery. It's got to go through our meter, through our cable here, through our meter, through the negative side, and back to the battery terminal. This is how you want to measure current. Must go through the meter unless you have an inductive probe of some sort. And you might have some clamp on, something that goes around a wire, which will accurately measure current as well without having to be intrusive in the system. That's another good feature about an inductive probe like that, is you can't blow a fuse with it. So it doesn't matter how much current you pass through there. It's not going to short anything out. So now if I'm looking at this meter, I have 0.002 amps, which is the same as 2 milliamps. It's 2/1000th of an amp. So this is very low, and this is accurate for this car. A car this age doesn't have a lot of electronics that are supposed to be drawing anything. So normally we like to see maybe around 20 milliamps or less on a modern car. Some cars up to 40, 50, or 60 milliamps pretty easily if they have a lot of computers and things. This one's all the way down to 2 milliamps. But what I want to do is show you what would happen. Let's say you had a dome light that was stuck on. Or you had a door pin switch that wasn't active, so it was keeping the dome light stuck on. I'm going to open a door up, and I want to show you what happens to the meter here. So we've gone up now to 348 milliamps, which is pretty close to half an amp of draw. Now this is enough. If this dome light was stuck on all night, when you come out in the morning, your car is probably going to be dead. 350 milliamps is way excessive, way more than the battery can handle, for 12 or 14 hours at a time. So right now we want to find the source of this. We'd have to go through all the fuses. There's a few different methods to check this, and I'm actually going to create a video for you how to determine where your parasitic draw is. So right now we've determined we have one. We've got 350 milliamps worth. The question is, well, how do we find it? Well, we got to systematically go to each circuit and either remove a fuse or measure the voltage across the fuse and convert that for the size of the fuse. Or there's actually some cool tools they make now, which I want to show you as well in the future here, where we don't even have to do that. We can just check the outside of the fuse like we were testing a fuse and measure the current that's flowing across the fuse. So that's really nice in modern days now, because a lot of these cars take sometimes hours even to go to sleep. And once we pull the fuse out, we've wakened everything back up again. We got to start the process over. So the method of pulling fuses systematically doesn't really work anymore. There are plenty of other places that we might measure current. Another good example might be an electric fuel pump. Sometimes we want to see how much current it's drawing. If the current is too high, it usually means there's a problem somewhere. If you get a fuel pump's rated at 10 amp current draw and it's drawing 12 or 15 amps, that might be a good indication that pump's getting ready to fail. So there's a lot of examples out here in the automotive world where you need to be able to measure current. And this, just like we talked about parasitic draw, there's a lot of other cool tools that we can use to measure current, like a lab scope with an inductive clamp set up on it is really great, because it allows us to see the pattern of electricity versus just looking at a meter. So we'll save those for another day. Let's get into the last use. We're going to be measuring resistance this time. And I mentioned this earlier, when we were measuring resistance with a digital multimeter, we usually want to remove the component from the system. So what I've done, I selected something that's fairly easy to get to so I can film for you. There's a vacuum solenoid back here, or a vacuum switching valve. It's designed to allow vacuum to flow through the valve when it's activated, and then once it's deactivated, the vacuum will stop. So what we want to do is we want to unplug the connector, which I've done already, and then we want to measure both the terminals. Only two terminals on there. It's just a coil of wire in there that makes the solenoid function. And we want to measure the resistance of that coil of wire. There is a certain specification for that. Now, you'll have to look that specification up to determine if it meets or is within specifications when you're testing the components. You need access to that information, okay? But I want to show you how the ohm test works, and it'll show you the resistance of that solenoid. So the first thing we need to do is make sure our leads are in the ohm setting, and then the common is obviously in the common port, and then we're going to set the meter here to ohms. And we've got it in auto range right now. Anytime you see your ohm meter in OL, just means it's kind of out of limits. You have no continuity whatsoever. There's nothing reading. So if I touch these meter leads together, you can see it drops all the way down to zero, basically 0.2 ohms, which is really nothing. Could be resistance even just in the leads or whatever. So nothing there. We always like to check our resistance before I do an actual test on a component. I like to put the leads together, just make sure that I've got 0 ohms, and then we can go ahead and put one of these on each terminal. So I'm going to stick on one side, and you have to really, some of these things are tricky in automotive applications to get to because we're not on a bench. Now I suppose we could take this out completely and strap it down on a bench somewhere so it's not wiggling around and moving around, but I wanted to just quickly give you an idea of how we're doing a resistance test on this particular vacuum solenoid. Okay, so if we look here, we've got 29.1 ohms across that solenoid. So we've got some resistance in there. It's in the range for this particular part. And if it were 0 or if it read OL, I would know OL would mean there was a break in the coil somewhere in the windings. We had an open circuit. If it was 0, I would know we had a short circuit. In other words, something inside had bypassed the coil of wire. The longer the spool of wire is, usually the more resistance you're going to have in there. That's how these solenoids work. Another way we can use the ohm meter would be for a continuity test. Continuity just means, do we have connection from one side of a wire all the way to another? So if you were under the hood with one end of a wire and this goes inside the dashboard and you're out by the fuse box underneath the dashboard over there and you wanted to see if that circuit had continuity from under the hood to inside the car, we could use this continuity test the same way. And we would basically just measure from one point. I'll just use this ground point here. Let's say we're just checking this ground even. We'll put these leads over here and see if we have this meter reading properly from one end to the other, where it's showing some continuity. Okay. And then if I were just to take this lead off, I could say, okay, well, I've got a break in the wire somewhere. There's other short circuits that we can test for. There might be a short to ground or short to power in a circuit. Those are a little bit more advanced tests, but this is a great way to check a wire to see if you have a break in a wire somewhere. All right, guys. So I've only barely scratched the surface with what this digital multimeter can do for us in the electronic world, automotive world. This is only a few examples of voltage, resistance, and amperage checks. There's plenty more out there. There's so much content we could create with this. If you guys really want to see it, just let us know down in the comments. We're happy to create some content for you, show you some in-depth tests, all those things. Appreciate you sticking along through this video. Hope you learned something, give you a little confidence to do some of this work on your own. And we've got plenty more videos for you out there in our playlist. Go ahead and check those out. Thanks for your support for the channel. Go ahead and click like and subscribe. This way you get more content like this in your browse feed. And we'll see you again in the next one.